Hello ROS developers and welcome to this new video section called Solving the ROS Challenge of the Week. In this case we are going to be solving the challenge number 3. And remember, this challenge of the week, this ROS Challenge of the Week thing, it's a contest presented by the construct where we present you with a ROS-related problem of different levels and you need to solve it. And the quickest one to solve this challenge will get a ROS developers t-shirt like this one. Amazing, right? So let's go for it. First of all, as always, we are going to copy the ROSject to our workspace. So let me click directly here, and this is going to copy this ROSject to my workspace, this challenge in this case. And yeah, so here I have it. As you can see, the ROS Challenge of the Week number 3. As you can see, in this case, this is an intermediate level one. The previous ones were beginners levels, and we also did in number 2, I think it was another intermediate. So this is also an intermediate level. And in order to open it, we need to click here in the Open ROSject, and this will start loading the environment. And meanwhile this is loading, let's come here. And let me remember you that you can come here to the Robotic Night Academy. This is our online academy where you will find many practical online ROS courses where you will be practicing and learning using simulated robots of many different topics. For instance, this one is this challenge. It's related to ROS manipulation topic. And for instance, here we have a course which is called ROS Manipulation in 5 days, where you will learn anything you need to know in order to solve this challenge and many others, of course. And yeah, you can find it here, but as you can see, there are many courses of many different topics like perception, TFs, IRTAP map, URDF for robot modeling, programming drones, etc, etc, etc. So here in our academy, you will get all the knowledge you need in order to be able to solve all the ROS challenges that we are going to be publishing in the future, of course. And yes, as I was mentioning, here in the ROSject you will find a notebook with instructions you need to follow in order to solve this specific challenge. Here you will find the instructions, and of course also you will find the instructions on how to claim your prize, what you need to do, the steps you need to follow in order to claim your prize. So as you can see here, our ROSject has already loaded, and we have here by default opened the instructions. So let's go for it. Let's start solving it. Let me close all this. And yeah, so the first thing we need to know is how to launch the simulation. This is the first thing we are going to do. So for this, as you can see, we can come here to the simulations menu and click in the choose launch file button. And then here we will choose the main.launch file from the Shadow Gazebo package. So let's come here to the choose launch file. And from the Shadow Gazebo package, we are going to select the main.launch and click on the launch button. So this will start loading our simulation, which when it's fully loaded should look something like this. Yeah. Then once the simulation is loaded, we are going to face the challenge to solve in this case. So here we have the steps, and as you can see, basically the main purpose of this ROSject is to be able to send a position goal to the manipulator, and the robot computes and executes a trajectory plan in order to reach this goal. Yeah? Then here you have described all the steps you need to follow in order to achieve this, which is what we are going to do right now. So for this, we are going to open a shell. There we go. And the first thing will be to launch this command here in order to start MoveIt, basically. So let's wait here. Okay, this is finishing loading. Excellent. So once this finishes loading, we are going to start MoveIt. There we go. Let me change here the camera to show you the full simulation. As you can see, here we have the robotic arm. And yeah, so let's launch this command here. First of all, let's execute it. Here we have some notes in case we get some errors here, which is not the case. Then this will open MoveIt, and in order to be able to visualize MoveIt, we will need to open the graphic and tools, which we are going to find here in the tools menu. Tools, graphic and tools. And then here we will be able to visualize MoveIt. I'm going to move this to a new window so that I can visualize it better. Excellent. Then here, as you can see, we will see something similar to this when MoveIt finishes loading. Let's see. Yeah, here it's starting to load. Now here, as you can see, this window is like displaced, so we can click here in this Resize Open It Up button in order to center it, and now we can maximize this. And here we have MoveIt. Now it will load here our manipulator robot. There we have it with the planning library and everything. Excellent. So here we have our manipulator robot. Let's center it here. Excellent. So yeah, let's keep going. So we have MoveIt loaded now. So the next step will be to select a goal. In this case, we are going to select here the goal state, and we are going to set it to this start position, which is predefined. It was defined at the moment when we created the MoveIt package. So let's come here to the goal state and select this start position. Let's click here on the update button so that the goal gets updated. There we go. And now let's click on the plan button so that MoveIt calculates the best trajectory to reach this goal. And there we go. It has finished it, and it's displaying here how this planet trajectory looks. And great. So now the next thing will be to click on the execute button so that this trajectory gets executed in the simulation. Yeah, in the simulated robotic arm, as you can see here in this image in the notebook. So let's click here on the execute the trajectory. And we got an error here. So it says it has failed. Okay, so yeah, here we can see some errors. Okay, so yeah, basically, as it also says here in the notebook, this is not working. So we need to figure out what's going on here and fix it. Yeah, so if we have a look here, we are going to see that it says unable to identify any set of controllers that can actuate the specified joints. Okay, so basically it cannot find any controller in order to control these joints, the joints of the arm, because he knows any controller. As you can see here, he says non-controllers and their joints, and there's an empty list. So basically, let's come here and open the IDE where we have all the code for this ROSject. And for this, you will need a bit of knowledge, which, as I've said before, you can get from the ROS manipulation course. And if you know a little bit of MoveIt or of ROS manipulation, you are going to solve this easier, of course. Then, yeah, so basically here, as you can see, we have many launch files. The one we have executed, for instance, is this one, the My Robot Planning Execution. But also we have here this Smart Grasping Sandbox MoveIt Controller Manager.launch XML. And this launch file, I already know that it's the one that loads the controllers from this file. From IARM file, as you can see, here it's loading the controller's configuration. Yeah, in this case, it's this file, mycontrollers.yarm. So let's come here to this file in the config folder. And let's see what it contains, mycontrollers.yarm. Okay, yeah, so as you can see, basically this contains nothing. It contains a string which is hi there, which means nothing to MoveIt. Yeah. So yeah, so definitely here there's an error. So we will need to fill this file with the proper controllers. But here's a little trick I left here in this challenge. Because if you have a look at all these files, you can see here another one which is named controllers.yum. Yeah? Then from this one, as you can see, this one is already filled. So hey, we can just come here, copy this to this file, We can do this, or we can rename this launch file so that it looks for the other one. It doesn't mind. So let me save this. In my case, I'm going to copy paste the contents. I'm going to save this, and let me try it all over again. Yeah, because here definitely I have found an error, and now I have fixed this first error, which doesn't mean that I have fixed all the errors. Yeah, so this is important. So I'm going to try to reproduce again all the steps so that I'm sure that I can plan and execute a trajectory with my robot arm. So let's do this all over again. Let's wait until MoveIt gets loaded. There we go. Okay. Let's put this properly. Let's wait until the robot gets loaded. So as you can see, MoveIt takes some time to load and everything. Okay, there we go. So let's come to the planning tab again. Let's select the start goal position. Let's fix it here. Let's plan the trajectory. Oh, there it goes. It's planning. Okay, so it has finished planning. Here it displays the trajectory, and let's execute it. Let's see what happens. And it fails again. Oh, damn. So it's failing again. Okay, so let's come back again here to the shell, and let's see what it says this time. So it says, unable to identify any set of controllers that cannot wait the specified joints. Okay, so now it's the same error, but now he's actually detecting some joints, but these ones are the ones from the gripper, which are not the ones that we want to control. We want to control the ones from the arm, not from the gripper. So there must be something wrong in the configuration of the joints of the arm, yeah, which are these ones here. These ones here. So let's have a look at this. So let's close this again, and let's have a look at the topics. So from what it says here, my controller should be named, let me do this a bit smaller, should be named ARM controller. So let me do a ROS topic list, and I'm going to grep here for ARM, and let's see what I get. Okay, yeah, so I have here the topics for the ARM controller. So they are there, and they are named ARM controller. So this is correct. The action namespace is follow your trajectory. This is correct as well. And then the type, here it says joint trajectory controller. So let me look for the type here. ROS topic info of the ARM controller, follow joint trajectory. And for instance, let me look for the goal topic. And let's see, okay, type, control, follow joint trajectory action goal. Okay, yeah, so here we have the second error. So you can see the type, it's not joint trajectory controller, but it's actually follow joint trajectory, yeah, because this is added, because this is an action and this is the specific topic of the goal, but the name, the generic name of this type is this one, follow joint trajectory, yeah. So this is the type I need to use here instead of this joint trajectory controller. So let me copy here, and in fact I have a hint here because it's the same type, as you can see, follow joint trajectory, follow joint trajectory. Okay, so let me save this file and let's execute everything one more time. Let's launch MoveIt again, and let's hope that with this second error we have fixed it. Now everything works properly. Let's see. Let me get a bit closer here. Of course, you can resize everything as you want. You can move them to a new tab, whatever you want. So yeah. Here it's loading MoveIt. Let's come to our graphical tools. Here it's loading arrays. Let me close this. Let's resize again MoveIt application. There we go. Let's wait a few seconds until this fully loads. There we have our arm. Okay, so let's start over again the process. Let's come here, let's set the start position as the goal position. Let's plan a trajectory, suitable trajectory. There we go. And once it finishes, there we are. Let's execute it. Okay. So let's come here to the simulation, and voila, here we have. So now it is properly executing the trajectory in the simulation. Yeah. So we have finally solved the challenge. As we can see here, the execution has completed in a succeeded status. So yeah, we have finally solved the challenge. So at this point, we would have to save our ROSject, clicking here, save our ROSject, and then follow the steps described here in order to share the ROSject. Yeah, so you would come here. Let me close already MoveIt so that it doesn't consume all the memory. All right, I can already close the simulation as well. All right, so yeah, here we have our ROSject. Then here we have the share links, but here probably you only will have the temporary link. So in this case, what you should do is to come here, edit the ROSject, and change the configuration to public. Yeah, once you make it public like this, let me update this. Once you make it public, you will be able to share the ROSject with no limitation, yeah, because otherwise the link will expire in 24 hours. So I won't be able to check if your solution is proper or not. Yeah, then once you have your ROSject, your challenge solved, you save your ROSject, then you come here to the share link, you copy the link, and then with this structure, which is presented here in the notebook, you will create a new tweet, yes, in your Twitter account with this structure, and substituting this part for the link to your ROSject, and that's it. Yeah. Then, yeah, the next Thursday I will evaluate the first one who has sent this and it's correct, and he will be the winner of the amazing ROS developer shirt. Yeah. So yeah, that's all for the video of today, and see you next Thursday with the ROS challenge of the week number 4, which is going to be of advanced level. I advance you. Yeah. So goodbye and keep pushing your ROS learning. Bye bye.